Hey, good morning everybody. Today's lesson is going to cover area of trapezoids, and just like yesterday I'm going to talk about the parts of a trapezoid, or the important parts at least of a trapezoid, and we're going to go over the formula and do some examples. Okay, so let's go ahead and get started. Okay, so now the first part of your notes here, we're kind of going over the bits and pieces of a trapezoid and what makes a trapezoid. So a trapezoid is a what? Quadrilateral. Quadrilateral meaning four sides. And it's a special quadrilateral because it's a quadrilateral that's not a parallelogram. What it is, it's a quadrilateral with exactly one pair, and only one pair, not just at least one pair. It's only one pair of
parallel sides.
So that means, like right here, that side is parallel to that side. Those are parallel. Those have the demarcations on them, the arrows right here, that indicate that they're parallel. So I went ahead and I just kind of put some parallel demarcations on those side lengths just to kind of show you what's going on there. The parallel sides on this trapezoid right here, those are parallel, and those are parallel. There's like one very typical looking trapezoid, and then these two right here, those are kind of atypical, not very typical looking, I guess. And it also should be noted that the other two sides, are not parallel because they're, if I were to continue along these, those paths, they would intersect, and that defeats the purpose of being parallel. Parallel means that they are segments or lines that will never ever meet. So obviously the other two sides are not so parallel. I don't know if I can make these meet. I can. I didn't draw that very well, but you get what I'm saying. Okay, so that's a biggie. That's a biggie. You want to make sure that it's a quadrilateral with only one pair, just one pair of parallel sides. And there's a name for those. The parallel sides are called the bases. So there's two bases on a trapezoid. We sometimes call them base 1 and base 2. You might see like a submarcation there of it might be a subscript there of base 2. And those are totally, absolutely, positively interchangeable. In that first one right there, I put base 1 on top and I put base 2 on the bottom. And the question I always get is, can they be the other way around? And the answer to that question is yeah. They can totally. We can call this base 2, and we can call this base 1. Now the important thing is that the bases are the parallel sides. That's the most important part. Like right here, this is not a base. And hopefully, from yesterday's lesson, you heard me say something about how bases don't necessarily have to be the bottom. And I think the next example is a perfect example of that. Right here, this is a base, and I'll just call that base 1, and I'll call that base 2. But those are the parallel sides right there. So that side and that side are parallel. And again, I'm not going to rewrite it, but those are totally interchangeable. I can make the left side of it base 1 and the right side base 2. It can be either way. And then on this one right here, again, we're just going to follow this rule here. I'm going to call this is base 1, and this is base 2. I really have no rhyme or reason as to why I'm naming those the bases, but what's important, like I said, is that the bases are the parallel sides. That is important. So right now, hopefully you got something out of that. On a trapezoid, the bases must be parallel. That is what makes the base. You got to get it out of your head that in geometry, that base, I know it seems like it should be, that base means the bottom. It doesn't. It doesn't always mean that. I know sometimes it does, but in geometry, not so much. Base kind of has a different meaning. So you got to get out of your head that base means bottom, because that's definitely not true. Bases, as they pertain to trapezoids, bases are going to be parallel. Okay, now moving on to the next thing here, we need to talk about the height. Okay, so the height of a trapezoid is and here's another big word, we talked about this the other day, perpendicular. It must be perpendicular. And remember, perpendicular means they meet at a right angle, 90-degree angle. They don't have to be like that. They can be any which direction, like right here. As long as where two segments meet is 90 degrees, then that's perpendicular. So the height of a trapezoid is the perpendicular distance between base 1 and base 2. So that's what we're talking about there. Basically, I've heard also that the height, another way to describe the height is the shortest distance between the bases. You know, that's another way to kind of put it. So on this one right here, those are the bases. And the height is going to be that. Now, how do we know that's the height? Well, you know, like I said yesterday, look for that right angle. If you see that right angle sign, that's telling you that is perpendicular, and that's a good indication that we're talking about the height. Now, in this example right here, the height is, and I know I don't have a right angle symbol here, but I'm going to assume, I should never assume though, I'm going to assume that that is a right angle right there. So the height, and this is where it gets weird, and people are like, it goes against their best instincts. But the height is actually that, and that's not typically, if I said, hey, what is the height of that trapezoid? I would say 9 out of 10 people would not give me that number or give me that dimension of that. But the height, remember, like I said, height has to be the distance from the parallel bases. Okay, so right here, that is not the height. Right? That's a diagonal. Remember how I talked about diagonals? They can't be height. When you're looking for the height, we're looking for where it's perpendicular from one base to another. Okay, on this one right here, I'm going to show you guys another kind of a way of denoting bases, but sometimes you'll see it like this. You'll just see the letter B and then the sub 1 or subscript 1. So I'll call that base 1, and this is base 2. So, and how do I know that those are the bases? Well, they're parallel. Now right here, is that the height? Or is this the height? So what do you think? And the answer to that question is neither. Neither one of those is the height. So we need a little bit more information about this trapezoid to say what the height is. So let's say I drew kind of a segment right here that came straight down from one base to another, and then I drew a right angle in here. Well, that is going to be the true height right there. Okay, because when we do height, we're looking for that right angle symbol. You know, and it could be really anywhere as long as it's perpendicular from one base to another. It could be anywhere. I think sometimes people get a little bit confused by that because they see, they're like, what did you do that for? Are you trying to show me that there's a triangle here? And I guess you're right, there is a triangle there. But really the only reason for showing that is to show you that from this point to this point, the base and the height are perpendicular relative to one another. Okay, so that's with trapezoids. I would definitely say that, you know, kind of all conventions kind of go out the window here because a lot of people, everything against their best instincts kind of, I guess with trapezoids, you know, I think the toughest part about trapezoids is just knowing what the parts are and having a good comfort level as to knowing what the bases are and what the height is with respect to the base or to the bases, plural. That is going to be really important. And also kind of knowing what numbers you don't really need. Okay, now let's get right to the formula for area of a trapezoid. And I have to warn you, it's a little bit is kind of long and it may look confusing, but I think what you have to kind of just keep in mind is that if you know what numbers to put in the individual parts, you're going to be fine. So let's go ahead and get right down to it. So the area of a trapezoid is going to equal this. It's going to equal 1/2 times, and then in parentheses, base 1 plus base 2. And that's the sum of the bases right there. So you might see the formula in a more condensed form. You might see it written like this. That's one way to do it. And then kind of like like I was saying with the triangle area, some people don't like that 1/2. They just don't like to have fractions as part of it. So if you want to, you could do height times base 1 plus base 2. This is an alternate way of figuring it out, but it all does the same stuff. And then just divide that by 2. But any way you do it, you're going to get area. Another thing that you got to keep in mind, and let me just kind of draw a little arrow here. Now that height right there represents the height of the trapezoid, which I know sounds obvious, but sometimes, especially when we get into volume questions and surface area, and where there's a lot of other things going on in the problem, it's going to be important that we know that height in particular, we're talking about the height of that trapezoid specifically. Okay, let's move on to example 1 here. Now, what I usually recommend for people to do is just make an organized list here of the bases and the height. All right, so the bases, and it doesn't really matter what you put where, but I'm going to say base 1 is 6. I'm going to say that at this 8 right here, this 8 represents, because sometimes people misread that 8 represents that segment from there to there. Sometimes people just see that, they're like, is that just talking about that part right there? No, we're not just talking about that. We're talking about the entire length of that segment from point to this point right there. So that's 8. It's okay if you want to put inches here. And then the height, again, look for that right angle. Then the height is 5. And another thing, like I think I maybe recommended this the other day, but when you do area, or if you're using any type of formula, this is right here, this is the formula for the area of a trapezoid, but I would recommend writing out the formula and then just kind of knowing where everything goes, because I think as 7th graders, just dealing with this stuff for the first time, it may be a lot to take in. Just go bit by bit and just kind of fill it in. So 1/2 is always going to be 1/2. And then instead of putting h, we're going to put the value that represents h, which is the height, and that's going to be a 5. So we're going to put a 5 there. Now I'm not doing any math yet. I'm just kind of filling stuff out. Now base 1 and base 2 are 6 and 8. And if you put 8 plus 6 or 6 plus 8, it does not matter one bit. Now there's a couple different ways you can do this. You can put it all in your calculator, of course. You can put in literally 1/2 times 5 times, and then use parentheses in your calculator. As long as you put it in literally exactly the same way you see it, it should come out okay. But let's just do this using good old-fashioned order of operations. So order of operations tells us that we should do parentheses first, or any type of grouping symbol. So we're going to do that part first. All right, so I'm just going to drop down the 1/2. That is not affected by anything. I'm going to drop down times 5, and then the 6 times 8 is going to be 14. All right, and then we can just go left to right here. Now 1/2 times 5 is 2.5. And then we're going to multiply that by 14. And that should be our area for that particular trapezoid. And then when we're all through with this, the area, A for area, is going to equal 35. Make sure you use the appropriate label when you're labeling answers for area, because that's always going to be square units right there. I don't know if anyone ever does this, just while I'm thinking of it, because this is what I did when I did in my head. Whenever you multiply by 1/2, I know this is 2.5, but it's got a 1/2 as a part of it. What I'll sometimes do is I'll break it up. I'll do 14 times 2, which, you can do that in your head, that's 28. And then I'll do 14 times 1/2. 0.5 is 1/2. And 14 times 1/2 is 7. And then you just put those together and you get 35. I don't know if anyone ever does that when you're dealing with multiplication where you have 0.5 as part of it. That's a little thing you can do. It's not necessary. You can just use your calculator. But it doesn't hurt you to kind of build up on those mental math arithmetic tips. Okay, same kind of example here. We wanted to identify the important parts of the trapezoid and then find the area of it. So let's make an organized list again. Okay, so the base 1 and base 2, I'm going to call base 1 10 feet. You can really call it 16, it doesn't matter. And I'm going to call base 2 16. And how do we know that those are the bases? What tells you that those are the bases? Now, what tells us that those are the bases? It's not that they're the bottom, or necessarily the top at the bottom, But what tells us is that those are parallel. That's how we know those are the bases. And then the height is the shortest distance from one base to another. So you're going to put 14 in there. All right, so now we're all set to kind of fill this out. If this is a lot for you to take in, in at once, and to kind of mentally process, just write out the formula. Don't put anything in. Just write out the formula. 1/2 times height times, in parentheses, base 1 plus base 2. Now you must use parentheses right here. So some people think like, oh, I can just do it any way I want. But the parentheses in this case, they represent that we have to do that first, and that is very, very important that we add those bases first before we do any multiplication. All right, so we're going to do 1/2 times h. Now the h is 14. The height we've determined is 14. Now base 1 is 10, and the base 2 is 16. And just like we did in the last one, let's just go through this using good old-fashioned order of operations and solve it that way. So parentheses come first. 1/2, I'm going to drop that down. 14 is not affected. 10 plus 16 is 26. All right, and then just solve it left to right here. You can really actually go left to right, right to left, start in the middle, go right, and go back to the very beginning. It doesn't matter because it's all multiplication. And order does not matter with multiplication. Now 1/2 times 14 is 7, and then you have 7 times 26. And that gives us an area of what? And I got an area of 182 square feet. Okay, now for number 3, it says find the missing base of the following trapezoid if the area equals 84. This particular problem right here, we're not looking for the area. The area is already provided for us. We're looking for a missing part. There's an element, there's a number here missing from one of the dimensions, and that's one of the bases. All right, so we'll call base 1 13. We'll call base 2 b because we don't know what it is. That's the unknown part. The height is 8, and actually right here I can add another important figure here, which we know that the area is going to be 84 square inches. And just like I have been doing all along here, I'm just going to go ahead and write out the formula for area with nothing really put in, no numbers in their place. So area equals 1/2 times height times the sum of the bases. So this is one where we have the area. The area is 84. I'm not going to put 84 square inches. I'm just going to use the number 84. 1/2 is just what it is. The height is 8. The base 1 is 13. And base 2 is b. On the previous problems, we were able to just jump right into order of operations and work on the parentheses first. But here, I don't know if you notice anything about the parentheses. If you were to try to work out the parentheses, 13 plus b, well, those aren't like terms. All right, so what does that mean? It does not mean like we're done with this problem, but it does mean that we have to kind of go about this and we have to use a different approach. And now let me write this kind of a different way, and maybe it'll make more sense to you visually once you see this. So I'm going to write it like this. 1/2 times 8, but I'm not going to write times. I'm just going to write parentheses 13 plus b equals, I'm going to put 84 over here. I'm going to write it more kind of like a typical looking equation. And the thing that I'm trying to show you here is that we're still going to attack the parentheses first, but we're going to attack the parentheses in a different way. We're going to distribute. Now that might not be a word we've used in quite some time, but we're going to distribute. So when we are left with things that we can't necessarily do in parentheses, we can at least distribute the number that's outside the parentheses. So you're going to do 8 times 13 and 8 times b. So that's what you end up getting. And I'm going to leave 1/2 the way it is. So I'm going to put just 1/2 times, now 8 times 13 is 104. And then 8 times b is, don't overthink that, is just 8b. 8 times n is 8n. 8 times x is 8x. So 8 times b is just 8b. And then we're going to make that equal to 84. And then I'm going to work this out even more. Now right here, I have 1/2 times 104. That can be worked out. 1/2 times 104 is like 104 divided by 2. And that's 52 plus 8b equals 84. Now this is at this point right here, we've got a two-step equation. I know that like we did this earlier in the school year. I think we did this back in December, maybe December, January. But we talked quite extensively about equations. And I told you, like, we're not going to be through with equations by any stretch. That's a two-step equation. So when we solve a two-step equation, you want to undo addition or subtraction first, and you want to undo multiplication or division last. So we're going to subtract 52 from both sides. And I know, like, you're thinking, like, why aren't we subtracting 8? Well, that's next to the b, and that's multiplication right there. And that's really not what you want to do. You want to, let's attack that 52 first, get rid of that, and then rewrite it. So now we have 8b equals 84 minus 52, which is 32. Right, now it's down to a one-step equation, which means we're just going to divide both sides by 8. And so then we get b is equal to 32 divided by 8 is 4. So we just figured out what b is. So b equals 4 inches. Now that's pretty complicated. I totally agree with you. Like, you might have just done that with me and we're like, what did we just do? But this just takes a little bit of practice, and like I always said all year long, which is practicing these skills and getting good at them and not using shortcuts is going to help you. If all you ever used is shortcuts, this is going to be really difficult for you. Knowing how inverse operations work, knowing how the distributive property works, knowing how to solve a two-step equation, those are all very important skills to know how to do. And if all you have is little shortcuts and little fast ways that worked for you just right when we were doing that, and that's probably not going to work out so well for you right now. Now for this next one right here, this is basically kind of the same kind of example, but I want you to try this on your own. And this is a good point where you can pause the video and try this on your own and really try it yourself. Don't copy just me. I mean, I know you're probably going to unpause the video and go through it, but really try it. Try to do it yourself and try to see if you can problem solve this and figure it out. This typically is where people kind of fall apart and they're like, what's going on? How do I solve this? And just like I was saying before, we can't add 32 plus x. Parentheses come first, but we can't do what's inside the parentheses. So we're going to do the next best thing, which is distribute the number that is just outside the parentheses. So we're going to clear those parentheses by multiplying by 20. So I'm going to leave 1/2 alone. And then 20 times 32 is 640. And then 20 times x is 20x. And then drop down the equals 820. Now 1/2 times 640 is 320. And I think some people get confused when it's written like this, so I'm going to write the x term first. So 20x plus 320 equals 820. Now it's a basic two-step equation. So what should we do? Should we divide by 20 or should we subtract 320 first? So what we're going to do first is we're going to subtract 320. So subtract 320, what you do to one side, you do to the other. And then remember, rewrite the equation. We've got 20x equals, and now 820 minus 320 is exactly 500. And now it's a matter of just dividing both sides by the number that's next to the letter. So the number that's next to the letter is 20. So we're going to divide both sides by 20. And here, of course, if you want to use a calculator, you can. 500 divided by 20 is 25. So we just figured out the other side there. So that's kind of weird. That definitely looks weird. I'm going to change this before I send this to you, but why would... All right, this is where things like don't make sense, but why would 25 be there? This is a shorter, and that's the shorter segment. I think this 32 was supposed to be down here. But anyhow, I'm going to trust that we did the math right. X equals 25 on that one. The bases are 32 and 25. It's just that the 32 probably should have gone as the longer segment. 25 should have been the shorter one. Okay, so for the most part, really, I want you guys to kind of know how to do the basics here. How do you guys do the area of a trapezoid? That's an important part. Knowing what the bases are is important. Knowing what the height is with respect to the base, that's important. Okay, and then there's a few algebra problems here that I want you guys to be able to do. I don't think I'm going to make that part of your assignment yet, but we're going to get there. I want you guys to be able to do that. Okay, so everyone have a great day, and that does it for your lesson. See ya.